All right. This is Coach Osborne. I'm going to be doing the Chapter 5 sequence test review. Okay, just remember this must be done and completed and turned in on the day of the test. All right, so first, we need to circle and identify several factors of each sequence and make sure to show your work. Okay, so right here, I need to see, is this multiplying a factor or is it adding a factor? So as I go from here to here to here, I notice that it's actually adding 5. Okay, so then that means that this is an arithmetic sequence, which also means it's increasing with a common difference. If it were like multiplying, such as in the next one, then you'd call it a ratio. But if it was kind of a pattern where it's neither adding or multiplying a constant factor, then it would be neither. Okay, and that also makes it linear. Anytime it's arithmetic, you know that you're going to have the linear and a common difference. Okay, so now for the zeroth term, now just a reminder that zeroth term is not the -8. It's not the first term. That's actually term 1. We call that term 1. The next one is term 2, term 3, and so on. Okay, so that means the zeroth term is going to be the one before. Now, if we're adding 5 going to the right, then that means to get to the 0 term, we'd have to subtract 5. So that means it's -8 minus 5, which is -13. So the 0th term is -13. And then simply, this is talking about the 4th term. What's the 4th term? And that's our 7 here. Okay, so now we have to create an equation. Remember, you always start with t of n. And we're using the format of slope-intercept form, which is y equals mx plus b. Okay, so remember that the y, instead of y, we're using t of n. Okay, now our m is the same thing as the common difference, which is that plus 5. So 5. Then the x, instead of x, we use n. And then here, we're not going to put the first term in our sequence. We're going to put the 0th term, okay, whatever t of 0 is, so the -13. Okay, so now this one, now if I try to check to see if it's adding, well, I notice that from here to here, it's 300, but then from here to here, it's 600. So it can't be adding because it has to add the same. But then I notice, okay, well, what if I multiply 2? Okay, multiply 2, I get 600. Multiply 2, I get 1200. Multiply 2, I get 2400. So that means that's a ratio whenever you multiply. Okay, so that also means it's geometric and it's exponential. And you notice that they kind of fall in line. So if it's ratio, it's geometric, exponential. It's common difference, it's arithmetic and linear. If neither, it's neither, neither. Okay, so now it's asking for the first term, not the 0th term, but the first term. Okay, the first term is going to be 300. Okay, in the sequence. Okay, and then the 5th term is going to be 4,800. Okay, so now it works a little bit differently when you're dealing with a geometric sequence. You're not looking for the 0th term in this case. In this case, you're actually going to start with I apologize. So no, we're actually going to start with the 0th term. So we do need to find the 0th term. So if we're multiplying 2, okay, so then we're going to divide 2. So that's your 0th term. So when I create my equation, we're going to use the format that t of n is equal to, okay, your starting value times, okay, your multiplier raised to the nth power. Okay, so that's the equation. That's how you write it out. So I'm going to write t of n equals the start value, which is your 0th term. Okay, so remember that start value is that value there, your 0th term. So in this case, 150. Okay, times the multiplier, which is 1/2. Times 2, and then you raise it to the power of n. Okay, so the 0, the 2, that's your multiplier. Okay, and then going back here, let's circle things to kind of line things up. That's your common difference there. And then for this one, your 0th term comes from that number there. Okay. Okay. So now the next one. Again, if you notice, it's a straight line, so I know right away it's linear, which also means it's arithmetic. It means it's adding, which means there's a common difference. Now, to find that common difference, we need to figure out the slope. Okay, so slope, I need to go from one point to the next. I need to figure out the rise, which is 1, and then the run, okay, which is also 1. So it's 1 over 1, okay, which is 1. So the common difference is 1. Okay, so now the 0th term right here is wherever the y-intercept or the b is. Okay, it's that one right there, which is -1. Okay, the 3rd term, okay, well, I have to remember that this represents x. So I go to the x value of 3, and then I go up and I say, okay, well, that 3rd term is 2, if you look at the y value there. Okay, so now let's create an equation. So t of n. Okay, so remember our common difference or the slope is 1. Then we put n. And then we need the 0th term right there, so -1. And you could just write that simply as n minus 1. Okay, so there's all your equations there. All right, so now let's go to number 2. Case number 2, graph it as continuous. So that just means when it says continuous, that means we just need to connect all the dots. So when we get to that point, I'll show you what I mean. Okay, so make sure to label the axes and find the following information about the situation. Okay, so now let's first look at the labeling the axes. Well, here, remember, this is x and this is y in a table. So the time here in years. Okay, and then that means the y-axis is the population in the millions. So I'm going to flip this around. Okay, so there's the label. There's the axis is labeled. Okay, so now I'm going to go to 0 and 0.1. So that's right here. Okay, and then the next point is 1 and 2.5. Sorry about the noise. So 2, this goes by 2, so 2, 4, 6, 8. So 2 is here, so about 2.5 is about there. Okay, so we got that. So now 2 and 6.5. 2 and there's 6. So 6.5 is about there. Okay, so 3 and 15.5. That's 14. That's 16. So about right there between. Okay, and then 4 and 41.5. Okay, so 4, I'm going to go up to about, there's 42. So 41.5 is a little bit below. Now remember, it said to graph it as continuous. So that just means we need to connect the dots. And in this case, we would connect the dots because this is a continuous problem, okay? Because in between each year, the population is continuing to grow. Okay. All right, so now independent variable. Independent variable, always the x. So it's just your time in years in this case. Okay, and dependent variable, that's always the y. Okay, so that's going to be your population. And in this case, in millions. Okay, so now choose one of the following for each. Is this linear or exponential? Well, linear, I know it's a straight line, kind of like this problem. So it's definitely curved, or sorry, exponential. Okay, and then is it increasing or decreasing? Okay, well, this would be increasing because going from the left to the right, it's increasing and it's going up. Okay. Okay, now the last problem on the page, number 3. Okay, so you'll notice here that it says Ali wrote the explicit equation T of n equals 3 minus 2 to represent the amount of money in his bank account. That's all the information we need right there. There's our equation that we're going to use to answer all these questions. Well, first, what's the first 4 terms of this?